Geometric mean is the nth root. We've talked about radicals before in this class. Square root, cube root, fourth root, nth root. We've talked about this before. The geometric mean is the nth root of the product. What does product mean? Multiplication. You're multiplying terms together. The product of n terms or values. The geometric mean is the nth root of the product of n terms. Let's go ahead and write that down, and I'll feed you baby birds, don't worry. However many terms you have, or how many terms you're trying to find the geometric mean, that's what root you're going to take. That's the index of your radical. So if I had 3 terms, like the values 5, 6, and 7, if I want to know the geometric mean of those 3 terms, 5, 6, and 7, I would multiply them all to each other, and then take the cubed root, meaning take the 3rd root of them. If I had 6 values, so let's say I had 6 terms, let's say 1, 3, 5, 7, 6, and 9, I had these 6 terms. If I wanted to find the geometric mean of these 6 values, then I would have to take the 6th roots, and so my index would be 6. Like a square root, the index is 2. Cubed root, the index is 3. So the 6th root, because I have 6 terms, of this product, 1 times 3 times 5 times 7 times 6 times 9. And I would take the 6th root of that. That's what this geometric mean is talking about. Now, in this class, geometry, we are mostly going to be dealing with the geometric mean of only 2 values, 2 terms. So if I have 2 terms, n is equal to 2, then what is the 2nd root? What do we call that? Square root. Okay, so aka square root, that is the 2nd root. So if I have these 2 values, 10 and 15, and I want to know the geometric mean of 10 and 15, that means I'm going to take the square root. I don't need a value here, because if there is no value, I know that's just the square root. The square root of 10 times 15. 10 times 15 is 150, and then I would have to simplify that radical. The square root of 150 is 5 square roots of 6. So that is, 5 square roots of 6 is the geometric mean of 10 and 15. You need to understand the definition. This is the generic definition of geometric mean. Any number of terms. This is what we're mostly going to be dealing with in blue ink, where you're taking the square root of 2 values. You take the square root of the product of 2 values. This is what we're going to be dealing with most. Highly doubtful, but maybe you'll see the geometric mean of 3 values as a bonus. We're going to be dealing with this, though. We need the geometric mean of 2 values. Now, if you look at your textbook on page 279, textbook gives a little different definition of geometric mean, does it not? it says the geometric mean of two positive numbers a and b is the positive number x such that a over x equals x over b. When solving, x is equal to the square root of a times b. Notice that their definition says the geometric mean of two positive numbers is this, and then they go off. My definition I've written in the board in blue ink is the generic, you can have any amount of terms, 6, 7, a million, whatever. They are focusing strictly on if you want to know the geometric mean of two values. And this is a true definition, that it is that x, the geometric mean, is just the square root of a times b, whatever those two values are. So you need to understand that this is the generic definition, and then in your textbook they are strictly talking about two values. Strictly talking about two values. So yeah, that correlate means that it has relationship to, or it comes from this given information. So in this aspect of more or less with logic and reasoning, when you have a theorem and then something follows or comes from that theorem, we call that a corollary. So what's going to happen is we're going to learn the right triangle altitude theorem. We're going to learn that, prove it, all kinds of fun stuff. And then we're going to see, well, what are the implications of that theorem? What does that imply? And then those are considered to be corollaries. So any theorem that exists has corollaries, but this is just the first time your textbook has used that term. Corollary is a statement that follows from a theorem. So there's two statements there, and whether they're conditional statements, it doesn't matter what form they're in. They are true statements that come from a theorem. The reason I'm doing this is because I want us to be able to go through this activity just smooth sailing. I don't want any of us to get to a certain part of this activity and be like, ugh, what's a corollary? Like, what is that? And then you stop listening to me and you're just trying to figure out what corollary means. Or, I don't want you to get home, start doing this homework, and just be like, I have no idea what that is, I don't know what it's asking for, so on and so forth. So I'm giving that opportunity now so that it's just smooth sailing. Kind of the method to my madness. So speak now, or tell me next class. We all good? We savvy? Alright, so this is what I want to start doing before we just dive into a new activity or a new lesson. Let's just kind of break it down, get a feel for it, so it's just smooth sailing through it. So let's dive into it. Page 275. We're going to attack this activity the same way we did activity 16. That means you guys are in groups, and we're going to do kind of chunk this activity and just kind of break it up into parts. So I'm going to give you a section of the activity to complete, and I want you to stop where I told you to stop. Again, there's a reason to what I'm telling you to do. There's a method to my madness. So on page 275, don't skip over the learning targets and the paragraph that's above item 1. Don't just skip over that. Read it, understand it. You need to know what is going on in this situation. Because this diagram and this whole thing that's in all of the learning targets where it says an altitude is drawn to the hypotenuse of a right triangle, you need to understand what's going on in this diagram and why these statements are true. So please don't just try to answer the questions. This is not a race. If you finish first, you don't win anything. But if you actually discuss and talk with your group mates, you'll get more out of that than finishing quickly and then gossiping about that cute boy at lunch or the little girl or whatever. Alright, so 1 through 4. That's the first chunk. 1 through 4. Go ahead and do that. And when you answer number 4, just please stop there. these three angle measurements. Now, before we answer these questions, I'm sure you have the correct answers, but I just want to make clear my expectations. If this were to be a proof, and you were to, if you ever had to relate these three angles, this is unacceptable. If you are forced to name one of the angles using the three-letter process, you need to stay consistent. So I don't like this. I'm just letting you know that in my proofs, if it's relating to other angles, I need you to use the three-letter process. Okay? And we'll get more into this when we actually do reach the proof on that page. But anyways, the measure of angle MAN, what is its measurement? 20 degrees. What is the measurement of angle EAN? 70 degrees. And the measure of angle E is 20 degrees. 20 degrees. Now the reason that they chose to put the measure of angle E is because they could have called it angle AEN, and that's kind of the angle that's in this medium-sized triangle. And then they also could have called it angle AEM. That would be an angle inside of the large right triangle. We have to understand that when we're looking at this diagram, there is the original large right triangle, triangle MAE. And so that's what we're starting off with. And then we, or they, the authors of this, drew in this altitude. When you draw in that altitude, you're splitting that large right triangle into two other small right triangles. And we're going to stay consistent with that terminology. We're going to refer to that original right triangle, we're going to refer to that as the large right triangle. It's the largest right triangle in this diagram. Then we have the wee little lad here, the smallest triangle. It's a right triangle still. And then we have a medium-sized triangle there. So we're going to use that, small, medium, and large right triangles in this diagram. Whenever you draw the whenever you draw the altitude to the hypotenuse of a right triangle, these other two right triangles are always formed. And we're going to refer to them as the small, medium, large right triangles. Off to the side here, I want you to redraw and label the three right triangles that are in this diagram. However, I want you to draw them so that they are in the same orientation. Every single one of them is in the same orientation. I want the right angle to be in the bottom left corner. That means I want to look like this. So the large triangle, this is A, this is M, this is E. Please draw the medium and the small triangles in this orientation and label them correctly.